class. Number 8. Number 1. Number 1. Let's go in order, class. Here we go. So we've got 72 degrees. So here we go. First thing I do is circle the angle, the acute angle that I'm given, label my triangle. The first side I label is my hypotenuse because that's the side that never changes. It's always across from my right angle. The next one that I personally always label is my opposite because it is opposite the angle that I circled. The other one left over is the adjacent. Okay, did you label your triangle correctly? That would be the first thing I would ask. Next, here we go. Some old horse caught a horse taking oats away. If you look at your picture, what do we know absolutely nothing about? Nothing. The adjacent, mark it out. If I mark out adjacent here, I mark out anything with an A over here. Oh, I guess we have to use sine, right? That's what's left over. Sine of 72 over 1, which is equal to opposite over hypotenuse, x over 10. And then I cross multiply. Okay? 1 times x is x. And I don't show this in my own work, but to show you guys, I'm going to show this step. Make sure your calculators are in degree mode, and you'll get sine of 72, enter, times 10, enter, and you get approximately 9.5. Okay? Good on that one? All right, number 8. Somebody said 7 before that. So let's do 7. Nope. Here we go. Because if you want time to do homework, then I might would let me get on with it. Yep. There's your x, 1743. All right, we're finding angles this time. The process is the same. Circle the angle that you're given. That's the only acute angle that I'm given. Label your triangle. Some old horse caught a horse taking oats away. Which side do we know absolutely nothing about? Opposite. Mark out all of these with an O. Excuse me. You using my homework time. Using your own. Cosine of x is equal to adjacent over hypotenuse. Now, here's the thing. When you're finding an angle measure, I know that I've got to find that angle by using the inverse cosine. And it's all calculator work, folks. Second cosine, 17 divided by 43, which gives you approximately 67. I'd appreciate if you'd stop whispering. Okay? 67 degrees. Questions? Does that help on 7? Do I still need to do... Okay, we've not done a tangent. Let me do 8. So 8 is this one. We got to find this angle down here at the bottom. We're given 33. We're given 39. Again, the process is the same. Circle the angle, label the triangle. And notice I label them in the same order every single time. Which side do I know nothing about? Hypotenuse, which means I have to get rid of cosine and sine for this one, and I have to use tangent this time. So tangent of x is equal to opposite over adjacent, which is 33 over 39. And again, we're solving for an angle measure, so I'm going to use the inverse tangent. 33 divided by 39. And when you find that value, it ends up being approximately 40 degrees. Okay? Questions. I want you to have this in your notes, okay? Because somebody asked first block, how do you know when to take just the straight up sine, cosine, or tangent, or when you have to find or use that second cosine, sine, or tangent? And I said, okay, that's a good thing. So let's review just to have it in your notes. And I want everybody to have this in your notes because, Lord have mercy, if I were to take a notebook quiz on this and you didn't have it, that would really suck. And I assure you, when I do a notebook quiz, it's going to be all this obscure stuff that I'm going to be looking for because I like to bust folks. Okay? Because I'm just kind of evil that way. Finding side measures. Yeah? Yes? Haven't I said that? Haven't I told y'all it all had to be in chronological? It needs to be in chronological order. I know I've said that. I think I've said it. Have I said it in this class? Teach 3 of these. Pardon me? Yeah. I'll tell you what to look for, and then I'll go down the rows as fast as I can, and you better have your finger right here. And if it's not when I get to you, tough tootie, I'm moving on. I got 30 of y'all, okay? So here I will shake it up, but you have to tell me, okay? You have to tell me. I will start on one side, I'll go to the other side, I'll start here, I'll go to Kaylee, I'll start here, then I'll go to the back. Maybe. I don't know, I just said that to make you happy. Or maybe not. Let's look at this triangle, finding side measures. Let's say that you had this. This was the picture. And you're told to find x, okay? You got to remember that when you're finding side measures, you're going to, bless you, you're either going to have sine, cosine, or tangent of any angle over 1, because remember this is where you use the proportion, which is equal to a side over a side. And I know that looks funny, but where will the unknown be? The part we're solving for. Will it be on the left side of the proportion or the right side of the proportion? It'll be the right side, okay? So your unknown Any? Okay. Why did I put sine, cosine, tangent?
No, I just said left side.
Did I say the left side?
No, she said right. Oh, I just said right.
Because your unknown is going to be on the right side of your proportion. Okay? Your unknown, your variable that we're solving for. Okay? All right, now your unknown is on the right side. Folks, please stop talking. And folks might be able to hear. And how do you solve this? You solve it by solve the proportion by cross multiplying. And dividing. Some of you need these in your notes. Okay, bless you. But your unknown's going to be on the right side when you're solving for a side measure. And all you do is just cross multiply and divide. I want to do this. Tired of solving these. We have the angle. We got the opposite. We got the hypotenuse. Folks, if I'm given the opposite and the hypotenuse, what am I going to use? Sine of 32 degrees divided by 1 is equal to the opposite over the hypotenuse, right? And then we get x is equal to sine of 32 times 15, and it gives us approximately 7.9. And I solved that really fast, but folks, at this point, you ought to be solving these problems that fast. This is geometry. This right here, that's geometry, okay? Pardon me? Oh, you can't multiply that in your hand? Yes, you can. I've done it first block. I did it first block. So, yes. Shh. No, it doesn't matter. No, it just lends for me. I want the X on the left. I always want my X on the left side, so I just put it over there. It doesn't matter. Okay. All right, now, holy moly, let's find these angle measures. Pardon? Can't hear you. I'm just hearing mumbling. Finding angle measures. I seriously can't hear you. Okay. Here we go. So your picture would look like this. Look where the unknown is now. My X is actually an angle measure. Okay, it's in the place of an angle. So what's it going to look like? How do we solve it? Well, we come over here, and we're going to set it up that same weird thing. It would be sine, cosine, or tangent of our variable X, or Y, or theta, or alpha, or whatever it is. It's going to be equal to the side over the side. And your unknown is the angle itself. That's what we're looking for, okay? This is just a guide to follow. Depending upon the picture, we don't know whether we're going to use sine, cosine, or tangent. That's why I'm listing all of them, okay? Now, something changes because we have to use, when we find angle measures, we have to use the inverse function. And remember, it looks like cosine -1, sine -1, tangent -1. That's where we use that second button on our calculator, okay? Second cosine on our calculators. Now, how would I find X? How would I find X for this? Do the same thing I've been doing, okay? Circle your angle, label your triangle. My opposite has nothing, my hypotenuse, my adjacent. Do you guys agree with me there? Just label in the triangle. What do I know absolutely nothing about? My opposite, I just have my adjacent, my hypotenuse, some old horse, caught a horse. Which trig function do I use? Cosine. Now look at this one. Cosine of X, because it's cosine of the angle, that's what I'm finding, is equal to caught a horse. Adjacent over hypotenuse. How do I solve for that? Can't cross multiply on this one because I've got to use the inverse function. That's what it tells me over there. So I'm going to have X is equal to the inverse cosine of 14 over 25. That's what the bottom half of your worksheet was last night. I could, but when we're solving for an angle measure, it's so much easier just to go. If I see cosine, sine, or tangent of a variable, I automatically know. You know how when we solve this, you don't write this down. But way back in this 7th grade, 8th grade, 9th grade, how would you solve 3y equals 15? You divide, and what you do to one side, you have to do to the other, right? I can't really, how do I undo, how do I get the variable by itself when we're talking trig function? The way I get the variable by itself is to take the inverse, because isn't this 3 times y, y'all? What's the inverse operation of multiplication? Division. This is the inverse operation, so that's why I do not set this up as a proportion. I just move it over, throw that -1 over top of it, and we're good to go, okay? So what is the inverse cosine of 14 divided by 25? Approximately 55.9 degrees. And folks, don't forget, if we're solving for an angle measure, that it's got to be a degree measure, right? So that's just a review, quick review, something good. Some of us need a guide in our notes, so there it is. Some of us need to go back and rework this worksheet. Go back and do it. If you didn't do it, I would do it. All right, so where's this leading us? This is leading us into a new section, believe it or not. Section 2.2. And this is the intro to trig functions in real numbers. And I'm going to just tell you, some of you are not going to like this because I'm going to do some deriving again. You got to understand where this stuff comes from. It'll help you remember it. When you understand why, you don't ever have to memorize anything. You just know it. You get it. Okay? You've already learned the terminal points of the unit circle, right? You already know the terminal points. Or if you don't know them yet, you're going to know them all in the next 2 days. What's tomorrow, by the way? The whole thing. The whole thing. You better figure it out. I don't know why you wouldn't. Did anybody happen to fold their unit circle in half? Why would I suggest to you to fold it in half? Because it's symmetric. If you look at it, the numbers are going to be the same. If you fold it this way, if you take your paper and you fold it, what's that, hamburger? If you fold it that way, it's going to be symmetric that way too. Why would you not do it? All you have to know is the first quadrant. That's it. Now, with that being said, you already know this. You already know that if I draw this angle and I prepare my graph like that right there, it appears to be what kind of angle increments? It appears to be 45-degree increments, or give it to me in radians, pi over 4. Now, if I were to draw a literal angle right here, what is that angle that I have drawn? Pi over 4, right? This one right here? Do you agree? Pi over 4? That's the angle pi over 4. Folks, what's that ordered pair? Root 2 over 2, root 2 over 2. Everybody ought to be able to tell me that. And you ought to be able to tell me that immediately. Okay? Now, up until today, you have thought of ordered pairs as X and Y values. Do you agree? Okay? Getting ready to change your way of thinking a little bit. We're getting ready to hit trig wide open, okay? So you better get ready. Now, this is easy, very easy. You got to help, you got to hang in here with me because we're going to derive it. I'm going to show you why. And at the end, you're going to go, oh, is that all? Seriously, couldn't you just say it? Yeah, I could just tell you. Won't mean anything to you if I do, though, okay? Some of you still won't mean anything to you anyway because you don't care. But you're going to know, and I will know that you've been told, okay? Now, let's look at this. You're going to draw first quadrant, that unit circle for me. And we're going to look at a 30-degree angle. 30 degrees, do you guys agree that it's something about right there? Looks perfect, doesn't it? 30 degrees. Start at 30 degrees in that corner of that triangle, okay? Now, this always, what are we going to do here? Because I need to form, what have we just left? We just left right triangle geometry stuff, right? So what do I need to draw? And you've seen me do it. We've done it before. What is it? Drop that altitude. Put in that right angle. And just for kicks, what's the hypotenuse? 1. How come? Because the radius of the unit circle is always 1, okay? And if you remember, we won't derive this, but if that's a 30-degree angle, folks, what's the ordered pair? Root 3 over 2, 1/2. Oh, here's something I'm finding on some of your papers. Maybe not this class. But, folks, it's square root of 3. Some of you are writing 3 over 2, 1 over 2. It's the square root of 3 over 2. This is why. If you remember, the short leg of a 30, 60, 90 triangle is 1/2. The long leg is root 3 over 2. And we've already derived it. It's already in your notes. I'm not going to derive that again, okay? But let's say we go back to what we just got finished doing. What I just literally got finished doing. What would I have done to that 30-degree angle? If I step back and I don't really focus on the unit circle and I just focus on that 30, 60, 90 triangle, and I'm wanting to find sides here, what would I have done? What did I do just a few minutes ago? What would I have done to the 30-degree angle? Circle it, and then I would do what? Label my triangle. So let's do that. We're going to take this unit circle concept and we're going to go back to what we just got finished doing. Let's label the circle. Triangle. That's triangle. We're going to label the triangle. The 1 is the what? It's a hypotenuse. It never changes. It's always across from the right angle. What's the next side that I always label? Opposite. Which one's the opposite? 1/2. Because I know that already that in a, yeah, I said it, but we've already derived that in a 30, 60, 90 triangle, the pattern that we follow, the short leg is 1/2 the hypotenuse. What's 1/2 of 1? 1/2. The long leg is the short leg times square root of 3. Therefore, it is the root 3 over 2. It's all in your notes. I'm not going to rehash all of that, but it's in your notes, okay? Now, where was I? Root 3 over 2 is the adjacent side. Do you guys agree with that? Okay. Now, where in the world is she going? So how would I find my x value? Because if I'm looking at this, how do I get the x value? Is it the hypotenuse? Is it the horizontal distance? Or is it the vertical distance? How do I get my x value? How do I get root 3 over 2? It's my horizontal distance. That's my x value. How do you get your y value? If it's not the horizontal distance, it has to be the vertical distance. Okay? Now bear with me just a few minutes. So how do I get the x value? If I didn't know already that that terminal point was root 3 over 2, 1/2, how would I get the x value using trig ratios? What we just got finished doing yesterday, okay? How do I do that? Well, this is how you do it. We labeled our triangle. We circled everything. Some old horse caught a horse taking oats away. Folks, if I'm trying to find x, then which side up here do I not need? I don't need my y. Do you guys agree with that? So cover it up. I don't need the opposite. If I don't need the opposite, then won't I mark out my opposites here? Yes or no? Okay, this is all going back to what we did yesterday. So the cosine of what's my angle? 30 degrees is equal to my adjacent, which is my x value. That's what we're going to think about. We're not going to worry about the terminal point. Over the hypotenuse, 1. Okay? I want you to look at that. Because if I'm trying to find my x value here, is it my horizontal distance, my x value? Okay? Now, watch. If I solve this as a proportion, folks, it's going to give me x is equal to the cosine of my 30-degree angle. What the heck does that mean? That means that the x value is the cosine of any angle. I could draw any triangle in my unit circle, and the cosine value will be equal to my x in my ordered pair. What? Let's say it a different way. The x in my ordered pair is the cosine value. All I just did was just wrote it a different way. I hope you're writing this down. Because if you're not, I can guarantee you this will be what I check. Y value, let's think about that. How do you find your Y value? Do you use that same triangle? Look up here. How do you find the Y value using trig ratios? If I want to find my Y, my vertical distance right here, then I don't need my X, do I? And then look what I would have. Cover up the X. That would leave me with the opposite and the hypotenuse. Folks, which trig ratio uses the opposite and the hypotenuse? Sine. So if I were to take the sine of 30, because that's the only angle I have up there, then it would be the opposite, which was y, over the hypotenuse, which was 1. And if I solve that as a proportion, then it's going to say that y is the sine of that 30-degree angle, won't it? All right, now let's do the same thing. What's it mean? That means that the y, this board, the y in the ordered pair is the sine value of 30 degrees. Okay? Sine, cosine. We got one more. We got tangent. Tangent. Some old horse called a horse taking oats away. What are we going to focus on? Oats away. What's that focus on? Opposite over adjacent. Okay? Tangent. Tangent. Opposite over adjacent. Tangents equal to opposite over adjacent. That is from geometry, correct? Apply it to that triangle that's on your paper above. Tangent of 30 is equal to, what's your opposite over the adjacent? Focus on the variables, not the values. Your opposite is y, your adjacent is x, correct? Now, what we did very quickly, because the looks I'm getting are like daggers, and just know, in my heart, you might be getting them back too. Love you. It's all said in love. What is this? What is this? Okay? What this means is this. Huh? This is what this means. In the past, yep, it says huh. In the past, we have always thought of ordered pairs as what values? X and Y. In trig, we don't think of them in those terms. What is the X value? It's on your paper if you wrote it down. Oh, it's cosine. It's the cosine value of that angle. What's the Y value? Oh, it's sine. And then what? It is y divided by x, and hold that thought. Folks, from now on, we're not going to think of ordered pairs anymore as x, y in trig. We've got to think cosine sine. Now, how are you going to remember that? How are you going to remember what order that's in? Seriously, how are you going to remember which comes first, cosine or sine? C comes before S. Yes, it's in alphabetical order. That's how you're going to remember it now. That's exactly how you're going to remember it, that it's in ordered alphabetical order. Here's what you're going to do. This is the part, because you don't care. This is what you have to memorize. I appreciate your honesty. Tangent. All right, Easter's already said it's y over x. But we can't think y over x, Easter. What do we got to think? Can't think x's and y's. Sine over cosine. Oh, jeez. Okay, you've got to think sine over cosine. Now, how are you going to keep that straight? No, not necessarily. What do you mean, little over big? Oh, okay, that's how you may connect to do that. That's fine. If that's how you connect, that's fine. This is how I do. Look at this. You don't write this down. So I set everything up in proportions, right? Y'all see me do that. Is S and T close in the alphabet? So I'm going to put S and T close in the proportions. They all going to be on the same lines. They have to be on the same level. I don't care how you connect and how you remember that the sine has to be divided by cosine. I think my S and T has to be close, so I put them in the top together. Okay? That's what I do. Use it, don't use it. I don't care, just as long as you know it. This right here you have to memorize, folks. This will not be on any card. You have to memorize that your ordered pairs are now cosine sine, and tangent is sine divided by cosine. But wait, there's more. Let's look at the trig functions, because yesterday when we found angle measures, what did you have to use? Yesterday when you were dealing with those, finding those angle measures, how did you find them? Did you find straight up sine, cosine, or tangent, or did you have to find something else? You had to use the inverse, didn't you? So we're going to look at trig functions and their inverses. Trig functions and their inverses. Here we go. we know, folks, I'm going to go in the order that's on your calculator. All of your calculators. Don't we always say sine, cosine, tangent? It's always in that order. If you look at your calculators, it's in that order as well. Sine of any angle, theta, is your y value. Do you agree? Cosine of any angle, I'm going to call it theta, is the x value. Tangent of any angle is always equal to y over x, but we can't think like that anymore. We got to think sine over cosine. So it's sine of theta over cosine theta. Okay? This is the part you got to know. There's a reason we keep writing it over and over and over again. Okay?
You know when you do the sine over cosine or whatever?
Yep.
Do you like work them both out separately and put the numbers there?
Yeah. Sometimes. Sometimes. You'll see in a minute. Okay? Their inverse is sine. Okay? We're not going to call it sine to the negative 1 power. You call it this. CSC. That's how we abbreviate it. CSC of theta. CSC stands for cosecant. Okay? Inverses, folks, are nothing more than reciprocals. So if cosecant is just the reciprocal of y, then what is it? Say it again. 1 over y. Very good. It's 1 over y. Or 1 over sine. Okay? The inverse of cosine is SEC. That's called secant. And it's going to be 1 over who? X. It's just a reciprocal of cosine. The inverse of tangent's the easiest one. But you'll never get it. Cotangent. Its reciprocal is what? X over y, or cosine of theta over sine of theta. S goes with the T. C goes with the C. Okay? Now, what? How are you going to keep all these? Which ones automatically just kind of lend themselves? They match. They go together. Because if I told you, hey, we're going to have a quiz on trig functions and their inverses, which ones are the easiest ones to know that match together? Shut up. No way. If I were to randomly say, I need you to tell me the inverse of cotangent, immediately everybody ought to tell me what? Tangent, right? Doesn't cotangent and tangent go? Don't they kind of sort of match? Okay, this right up here, sine and cosecant, what the crap? Sine, CSC, what? That doesn't have anything in common at all. So this is, to me, the easiest one to connect to and keep together, that they match, they go together. The next one is this. Folks, look at this, cosine and secant. Does anybody see a way that I would, oh yeah, they kind of do go together. Anybody? There. What is our unit circle? What's the fancy word? It is symmetrical. Look at the words themselves. Yes. Vowel C. Do you see how they're symmetrical? Well, I didn't want to say E because somebody would have gone, but it's an O right there. So I said a vowel. These are symmetrical. Folks, if you know these on the bottom, if you know tangent and cotangent, they're given. Okay? The next one that's just as easy to remember is cosine and secant. And then the other one has to go with sine. It has to. You've got to know these. You have to memorize them. This is not going to be on the card anywhere. You got to know this. How are we going to use it? How are we going to use it? Here we go. I want you just to remember that the patterns for the special right triangles, and folks, this is already in your notes, but the 45, 45, 90 triangle, which looks like this, is 1, 1, square root 2. You ought to know that pattern. You ought to know it. The pattern for a 30, 60, 90 triangle, bless you, that's wrong. The pattern for the 30, 60, 90 triangle, and again, this is all in your notes. We've already gone through all this. If the hypotenuse is 1, the short leg is 1/2. The long leg is short leg times square root of 3. 1/2 times square root of 3, which is root 3 over 2. Don't ask me how I know that. It's in your notes. Go back and look at it. Okay? It's in your notes. But I'm giving you this again because it's going to lead into our example. And we're doing one example. That's it. Okay? Just one. We'll hit the meat of it tomorrow. Promise. One example. 6 parts. But it's one example. Why are there 6 parts? And they're inverses. Okay? You'll use half part. Yeah. All right, are we ready? Here we go. So here's what you're going to have to do. You've got to find all 6 trig functions. You've got to find all 6 trig functions. No, honey. This is our example. That's going to help you with your homework. Pardon? No. But remember, you got 6 parts. The angle is pi over 6. Folks, what do you know I'm going to do? You know I'm going to draw a picture of this. Is that which quadrant am I going to draw? First only. Because pi over 6 is actually what degree? 30, okay? Haven't we seen that already today? Just saying. Hypotenuse is what? 1. The short leg is 1/2. The long leg is root 3 over 2. You just have to know that. Just draw it in the unit circle because it applies to the unit circle. Okay? Now, you also already know that the terminal point for pi over 6 is what? Root 3 over 2, 1/2. If you know your unit circle, you already know that terminal point. You should already know that point. And now let's apply what you learned today. We're no longer thinking x, y. We're thinking what? What? Say it again. Cosine, sine. Right? Folks, do you really have to find 6 trig functions? Do you have to find 6? You only got to find 4 because you already know 2 of them. Don't you already know the terminal points for these angles? In the first quadrant, yes or no? How many of you know the terminal points for 0, 30, 45, 60, and 90 degrees? Hands up. You already know 2 of them. Okay? So, folks, what's this mean? Sine of 30. We shouldn't put 30. We should put pi over 6 because that's what we were given. Sine of pi over 6. Because remember, we always go in order, sine, cosine, tangent. We're getting ready to list them all, okay? Now, sine. Folks, it's already up there. What is sine? It's 1/2. From our terminal point, from the ordered pair, I already know that the sine value of my pi over 6 angle is 1/2. I also already know that the cosine value of pi over 6 is what? Root 3 over 2. How do I already know that? Because it's given. It's not really given, but it's given up here. It's already in our head, right? We already know it. Oh, tangent. Got to do a little figuring. If you had Dr. G, you're going to tear up your bracket thing. Don't ask me about the bracket thing. But I know that tangent is sine divided by cosine, isn't it? All right, sine divided by cosine. If you want to do the bracket thing, do the bracket thing. I'm not even going to draw it. I'm going old school, and I will always go old school. So check this out. What's my sine value? It's 1/2. What's my cosine value? Root 3 over 2. I'm multiplying by my reciprocal. Y'all can go on with your bracket, and that's fine, but I'm going to do what I feel comfortable doing. And I get 1 over root 3. One over root 3. Make that neater. Can I have a radical in my denominator? No. What I have to rationalize, don't I? So what do I rationalize? By root 3 over root 3? Yes? That gives me root 3 over plain old 3. Do you guys, you with me there? All I'm doing is rationalize because I can't have a radical in the denominator. So what's my tangent value? Root 3 over 3. Holy moly, Cindy, here we go, because we ain't done. Now we got to find their inverses, don't we? But do we really have to do anything? All we have to do is just say it again. Flip them over. Flip them over. Holy moly, y'all. What's the inverse of sine? CSC or secant? CSC, cosecant of pi over 6. Flip 1/2 and it becomes 2 over 1. Clean it up, it's 2. Right on? Remember, the inverses are just reciprocals. What's the inverse of cosine? Secant, good. All right, now, can I leave it like that or I got to clean it up a little bit? Clean it up a little bit. We got to rationalize again. Dang it. Multiply by root 3 over 3. And don't we get 2 root 3 over plain old 3? Y'all with me? Okay. Now I want to show you something. What's the inverse of tangent? Now, tell me what the name of it is. Cotangent. Okay. Now let me show you something. And it'll save yourself a lot of work. Go back down here to my work. What was the answer I had before I rationalized? That was my value, wasn't it? 1 over root 3. And then I rationalized and I cleaned it up to this. Flip it over. What do you get? You get root 3 over 1, which is root 3. If you don't, now I'm trying to show you a shortcut here. If you don't see that, you just rationalize again. Look what happens. Oh, yeah, I get the same thing, okay? I'm trying to save you a step. If you'll slow down and just look at what you've got. Now, folks, look at what we did. Look at what we did, okay? Look back. I said I wanted you to find the trig ratios, all 6 of the angle pi over 6. Did we have to graph it? No, you didn't have to. You ought to already know that the terminal point for pi over 6 is root 3 over 2, 1/2. Do you agree with that? So you don't have to do this, but it's going to come a time tomorrow that you're going to have to draw a triangle, okay? And it may not look like this, but we're going to use this triangle. Now look, How many of these did I really have to calculate to get? I ain't done. Hold on. How many did I have to actually calculate? Really, only one. Which was the only one, bless you, that I only had to calculate? Tangent. Because everything else I just had to flip it over and maybe clean it up by rationalizing, correct? You need to look at this and think about this. This is not easy. This is not difficult. It is very easy. It's not difficult at all. Really, it's not. If you take away everything of me trying to show you why, because quite frankly, 85% of you could care less. Okay? But guess what? You better figure it out when you get to college, because somebody's going to need you to care. So you better get your care on sometime. Oh, you better share some love. Okay? Here's what you need to do for homework. I want you to find all 6 trig functions for the following angles. 0 radians, pi over 4, pi over 3, and pi over 2. Folks, you already know 2 of them for each one. Just for kicks, find all 6 trig functions for those 4 angles. What's the ordered pair for 0 radians? Oh, look, you already know cosine and sine. What's the ordered pair for pi over 4? Root 2 over 2, root 2 over 2. Well, I'll be daggone. What's the ordered pair for pi over 3, folks? 1/2, root 3 over 2. And what's the ordered pair for pi over 2? 0, 1. You already know cosine and sine for all 4 of those angles. Now, here's my warning. When you get to flipping some of these, 0 and pi over 2, something's going to happen, and I just want you to remember, when 0 is under the fraction bar, what kind of number do you have? Thank you. When 0 is under the fraction bar, what kind of number do you have? Undefined. You better remember that.